Hey there, students. I wanted to do a problem illustrating how to find a confidence interval for standard deviation. So I have chosen number 40 on the homework set on 7.1 through 7.3, and finding standard deviations distribution issues are in 7.3. So the problem states, use the given information to find the number of degrees of freedom, the critical values, and they show this x squared sub L, which stands for the left critical value on the chi-squared distribution, and the right critical value on the chi-squared distribution. This would be for a confidence interval estimate of sigma, which is the population standard deviation. It is reasonable to assume that a simple random sample has been selected from a population with a normal distribution. So that statement that we are assuming we have a normal distribution population means that even though my sample size is below 30, I can use tactics from this chapter. Okay, and the information that's given is that nicotine in menthol cigarettes is going to be measured, and there's a 99% confidence interval that we're looking for, and we have a sample size of 22. And the standard deviation of the sample was 0.25 milligrams. So they give us an ability to use a chi-squared critical values table to look up some things, but we're going to just try to do everything in StatCrunch. And we're going to want to use that for the critical, confidence interval anyway, so we might as well do everything in there. So the first thing they ask for is the DF, which is the degrees of freedom. And the degrees of freedom is one less than the sample size. So since the sample size is 22, the degrees of freedom will be 21. So then they ask for the critical value of the chi-squared distribution on the left end of our confidence interval, and then they're going to ask for the right end, and then they're going to ask for the confidence interval. So how are we going to find these things? So to find chi-squared scores, we want to use the chi-squared calculator. So I'm going to go over, I've already opened StatCrunch. I'm going to go to Stat, Calculators, and then the fourth choice is the chi-squared calculator. So I'm going to click on that. And here it is. Now you'll see a chi-squared is a skewed distribution. It's not a standard normal distribution. And because we want a 99% confidence interval, we're going to go to the between calculator, and we want the area in between to be 99%, and the degrees of freedom we've already determined is 21. So then I'm going to put in the area of 0.99 for 99% interval, and it'll then tell me the left and the right chi-squared values for that interval. And so they say to round this to 3 decimal places, and the first thing they want is the left one. So I'm going to take the left number and the 3 decimal places, grab that. That 3 on the end needs to be rounded up to a 4. Then they want the right critical value over here, and I don't have to change anything for 3 decimal places here. Nice. Okay, so then they want the confidence interval estimate of sigma, which is the standard deviation of the population. So we want to produce a confidence interval. So for an actual confidence interval, we need to use the standard deviation of our sample and then use the correct values that would have these critical values for their interval. But for actually coming up with values of the population, we can't go to the calculator anymore, so I will close this. And instead, we have to go over to Stat, and for the standard deviation of the population, the calculator is actually for the variance. The chi-squared, the squared, remember the variance is the square of the standard deviation, so I'm going to go to Variance Stats, and I'm going to go to one sample with a summary. So again, that was Stat, Variance Stats, one sample with summary. So here we need to pay close attention, and this will really throw students off initially as they're trying to learn how to use this tool. we have to keep in mind that the variance is the square of the standard deviation. And so actually this calculator is completely dealing with variance. So it says, what is the sample variance? If you do a hypothesis test, it would be for sigma squared, which is the variance. Those won't come until chapter 8. We are doing a confidence interval, but the interval will be for sigma squared. And then we can put in the level we want for that, which was 99%. The sample size was 22. So I can't put in 0.25 for my sample variance because that's the sample standard deviation. What I have to do is I have to square the standard deviation to get the variance. And then later, if I have a variance value, I would have to square root it to get a standard deviation value. So 0.25 gets squared. 0.25 will get squared. And that gives me, I got to square it, 0.625. So the variance that I put in for the sample is 0.0625. Because that's the square of the standard deviation of the sample. So having put those in, I can then compute. And here I get my confidence interval. But again, what they're asking for in the problem is the confidence interval for sigma. And what StatCrunch gives us is a confidence interval for sigma squared. So what that means is I need to square root the lower and upper limits of my interval so that they are then an interval for sigma instead of for sigma squared. So I'm going to take this answer I got. I'm just going to take it all and only round off after I've taken the square root. Copy it, stick it in my calculator, and then I'm going to hit square root. So now that's the square root of the lower limit of sigma squared, so that should be the lower limit for sigma. And so this is to 2 decimal places, and I want 0.18 if I round that off, so 0.18. And then I do the same thing for the upper limit. Grab the upper limit for sigma squared, go to the calculator and enter that, and take the square root. And I got 0.40. 0.40. So now I've square rooted the lower and upper limits for sigma squared to get the lower and upper limits for sigma, because that's what my stat lab wants. So there you go. So pay attention to the details. Hopefully this example will help you, because you do have to do some translating between the StatCrunch calculator and the problem, what the problem wants in my stat lab. But other than that, you can pretty much do everything in StatCrunch. So keep up the hard work, and I'll see you when I see you.